Hi everyone, welcome back. In this video, we are going to discuss top Java collection framework interview questions and answers. Let's begin. What is the Java Collections Framework? The Java Collections Framework is a complete architecture provided by Java to store, manipulate, and manage groups of objects efficiently. It offers ready-made implementations of common data structures such as lists, sets, queues, and maps, along with algorithms like sorting, searching, and iteration. The goal of the framework is to make data handling consistent, reusable, and easier across the entire application. The framework provides core interfaces such as list, set, queue, and map. Each interface has multiple implementations optimized for specific use cases. For example, ArrayList is optimized for fast access, HashSet is optimized for uniqueness, and HashMap is optimized for key value lookups. The collections framework also includes utility classes such as collections, arrays, and comparator helpers, making common tasks like sorting or synchronization extremely convenient. The biggest advantage of the collections framework is that it eliminates the need to build data structures from scratch. Instead, developers use pre-tested, optimized implementations, resulting in cleaner code, reduced bugs, and better performance. This framework is fundamental for any Java developer preparing for interviews. Next, what is the difference between list, set, and map? A list represents an ordered collection where elements are stored in a specific sequence and duplicates are allowed. You can access elements using indexes, making lists ideal for tasks where order matters, such as maintaining user history, playlist items, or ordered menus. Common implementations include ArrayList, LinkedList, and Vector. A set represents a collection where duplicates are not allowed. Sets do not maintain positional indexes, and depending on the implementation, ordering may vary. HashSet does not maintain order, LinkedHashset maintains insertion order, and TreeSet maintains sorted order. Sets are perfect for storing IDs, emails, or any data requiring uniqueness. A map stores data as key value pairs. Keys must be unique while values can repeat. Maps are ideal for lookups, fast searches, caching, dictionaries, and configuration management. Common implementations include HashMap, LinkedHashMap, and TreeMap. Together, list, set, and map cover almost every data handling scenario in Java applications. Next question. What is the difference between ArrayList and LinkedList? ArrayList is backed by a dynamic array. This means elements are stored in contiguous memory. Accessing elements is very fast. However, inserting or deleting elements in the middle is slower because shifting occurs. ArrayList is best suited for scenarios where most operations involve reading data rather than modifying it. LinkedList is backed by a doubly linked list. Each element contains references to the previous and next nodes. This makes insertions and deletions extremely efficient because only pointer changes are needed. However, accessing elements is slower because LinkedList must traverse nodes sequentially. In practical terms, ArrayList is ideal for storing large datasets that require fast retrieval, while LinkedList is ideal for highly dynamic applications where additions and removals occur frequently. Choosing between the two depends entirely on access versus modification patterns. Next, what is the difference between HashSet and TreeSet? HashSet stores elements in an unordered manner and is backed by a HashMap internally. It provides constant time performance for add, remove, and lookup operations because it relies on hashing. HashSet is generally the most efficient set implementation when ordering is not important. TreeSet stores elements in a sorted manner using a red-black tree. Every insertion involves maintaining sorted order, making operations slower than HashSet. However, the advantage is that TreeSet allows sorted traversal, range queries, retrieving smallest or largest elements, and ceiling/floor operations. Both HashSet and TreeSet disallow duplicates, but HashSet prioritizes performance while TreeSet prioritizes sorting. In interviews, the key point is understanding when to choose which. HashSet for speed and TreeSet for sorted results. Next, what is iterator in Java and why is it used? Iterator is a cursor mechanism that allows sequential traversal of elements in a collection. It works for all major collection types such as list, set, and queue. The primary purpose of iterator is to provide a safe and uniform way to access elements without exposing the internal structure of the collection. Iterator supports three operations: next to fetch the next element, has, next to check if more elements exist, and remove to delete an element safely during iteration. Iterator is preferred over using indexing because not all collections support indexed access. For example, set does not have indexes, but iterator can still traverse it. Iterator also avoids structural modification issues because modifying a collection directly during iteration triggers concurrent modification exception. Using remove ensures safe modification. Next, what is the difference between iterator and ListIterator? Iterator is the basic cursor used to traverse any collection like set, list, or queue. It supports only forward traversal and allows you to remove elements safely during iteration. ListIterator is more powerful but works only with list implementations such as ArrayList or LinkedList. It supports forward and backward traversal, allowing richer navigation. It also supports adding and modifying elements during iteration. ListIterator provides extra methods such as previous, next index, and previous index, making it ideal for bidirectional operations and complex list manipulations. In interviews, remember that iterator is universal and simple, while ListIterator is list-specific and feature-rich. Next, what is fail-fast in Java collections? Fail-fast is a mechanism where iterators immediately throw concurrent modification exception if a collection is modified structurally while iterating through it. This prevents unpredictable behavior and ensures safety. Fail-fast applies to collections like ArrayList, HashMap, and HashSet. It is not a guaranteed mechanism but a best effort approach to detect incorrect modification. Fail-fast is important because modifying a collection while iterating can cause corrupted states, infinite loops, or inconsistent data. In multi-threaded scenarios, always use Concurrent HashMap or CopyOnWriteArrayList for safe iteration. Next, what is the difference between HashMap and Hashtable? HashMap is non-synchronized and therefore faster. It allows one null key and multiple null values. It is preferred for most modern applications where external synchronization or concurrent HashMap is used for thread safety. Hashtable is synchronized and thread safe but significantly slower. It does not allow null keys or null values. Hashtable is considered legacy and rarely used today. In interviews, emphasize that HashMap is the standard choice and Hashtable is outdated. Next, what is Concurrent HashMap and how does it work internally? Concurrent HashMap is a thread-safe implementation of the map interface designed for high concurrency environments. Unlike Hashtable, it does not lock the entire map during updates, which significantly improves performance. Instead, it uses a segmented or bucket-level locking approach. In Java 7, the map was divided into segments, allowing multiple threads to update different segments concurrently. Starting from Java 8, the internal design changed to a lock-free and bucket-synchronized system. Instead of segments, Java 8 uses synchronized blocks on specific buckets and caches, compare and swap operations for thread-safe updates. This drastically improves scalability and reduces contention during concurrent writes. Read operations are almost entirely lock-free, meaning multiple threads can access the map without blocking each other. Concurrent HashMap also converts high collision buckets into balanced red-black trees, ensuring consistent performance even when multiple keys hash into the same bucket. Unlike HashMap, it does not allow null keys or null values. preventing confusion in multi-threaded conditions. Overall, Concurrent HashMap is ideal for caches, shared state in microservices, thread save counters, and real-time analytics. Next, how does HashMap work internally? HashMap uses an array of buckets where each bucket stores key value entries. The hash code of the key is processed using a hashing algorithm to compute the bucket index. When you insert a key value pair, HashMap computes the index and the pair is stored in that bucket. If multiple keys hash to the same index, a collision, HashMap uses chaining to store entries in a linked list within that bucket. From Java 8 onward, if too many collisions occur in a single bucket, the linked list is automatically converted into a balanced red-black tree for faster lookups. During resizing, when the load factor exceeds the threshold, default 0.75, the internal array doubles in size. All entries are rehashed and redistributed across the new bucket array. HashMap allows one null key and multiple null values. It is not synchronized, so it is unsafe in multi-threaded environments unless externally locked. HashMap provides average time complexity for put and get operations, making it one of the most commonly used data structures in Java applications. Next, what is LinkedHashMap and when should you use it? LinkedHashMap is similar to HashMap but maintains insertion order or access order depending on configuration. Internally, it uses a doubly linked list that connects all the entries in addition to the hash table. This allows predictable iteration order. The most significant feature is the ability to maintain access order. When configured, LinkedHashMap moves an entry to the end of the list every time it is accessed. This makes it extremely useful for implementing LRU, least recently used caches. LinkedHashMap is ideal when you need a predictable order or caching behavior. Common use cases include web sessions, token storage, caching frameworks, and history tracking features. It allows null keys and values and is not synchronized, similar to HashMap. Next, what is TreeMap and how does it differ from HashMap? TreeMap is a sorted map implementation based on a red-black tree. Keys in TreeMap must either implement comparable or be provided with a custom comparator. TreeMap stores entries in sorted order, allowing range queries, submaps, floor, ceiling, and navigational views. HashMap, by contrast, stores entries in an unordered manner and relies on hash functions for fast access. TreeMap consumes more memory because tree nodes store extra pointers and balancing data. TreeMap does not allow null keys because ordering null is not defined, but values may be null. Use TreeMap when sorted order, range navigation, or custom ordering is needed. Use HashMap when performance is the top priority and ordering is irrelevant. Next, what is CopyOnWriteArrayList and when should you use it? CopyOnWriteArrayList is a thread-safe version of ArrayList optimized for scenarios where reads are frequent and writes are rare. Instead of synchronizing access, it creates a new internal array every time an add, remove, or set operation occurs. Because writes involve copying the entire list, they are expensive. But read operations are extremely fast and require no locking, making this list highly scalable in read-heavy environments. Iterators for CopyOnWriteArrayList are fail-safe, meaning they never throw concurrent modification exception. They operate on a snapshot of the list at the time the iterator was created. This structure is ideal for event listeners, subscriber lists, configuration lists, routing tables, and any scenario where data rarely changes but must be accessed by multiple threads safely. It guarantees thread safety without costly locking mechanisms, making it popular in concurrent systems. Next, what is the difference between fail-fast and fail-safe iterators? Fail-fast iterators immediately throw concurrent modification exception if the underlying collection is structurally modified during iteration. These iterators work directly on the original data structure. Examples include ArrayList, HashMap, and HashSet iterators. Fail-safe iterators do not throw exceptions because they operate on a cloned copy of the collection. Modifications to the original data do not affect the iterator. Examples include iterators in Concurrent HashMap and CopyOnWriteArrayList. Fail-Fast is used for debugging and protecting the collection from inconsistent states, while Fail-Safe prioritizes concurrency and stability over detecting errors. Fail-Safe iterators consume more memory because of copying, but are ideal for high concurrency scenarios like real-time analytics or multi-threaded caches. Next, what is the difference between comparable and comparator? Comparable defines a natural ordering for a class and is implemented directly within the class using the compareTo method. This makes the class self-sorting. Comparator defines external sorting logic using compare and allows multiple different sorting strategies without modifying the class. Comparable is ideal when objects have one consistent default order, such as alphabetical or numerical. Comparator is ideal when sorting must vary based on business rules, like sorting employees by salary, age, or department. Comparator is more flexible because you can create unlimited sorting rules without modifying the source class. Interviewers expect you to mention that sorting using comparable uses collections.sort method with list as parameter, while sorting using comparator uses collections.sort method with list and comparator as parameters. Next, why is equals and hashCode important in collections like HashSet or HashMap? Collections such as HashSet and HashMap rely on hashing to determine the bucket location of an object. When objects are stored, their hashCode determines the bucket, and equals determines whether the object already exists in that bucket. If both methods are not properly implemented, duplicates may appear, lookups may fail, or elements may become unreachable. The contract states if two objects are equal according to equals method, they must produce the same hashCode, but two objects with the same hashCode are not required to be equal. Proper implementation is critical for sets, maps, caching systems, and deduplication logic. For interviews, emphasize that incorrect equals and hashCode cause unpredictable behavior and bugs. Next, what is a priority queue and how does it work? Priority queue is a queue where elements are ordered based on their priority rather than insertion order. Internally, it uses a binary heap, ensuring the head of the queue is always the smallest or largest depending on comparator rules. Priority queue does not allow null values and is not thread safe. It is ideal for scheduling tasks, implementing Dijkstra's algorithm, event-driven systems, and anytime you need elements processed by priority instead of arrival. Next, what is a WeakHashMap and when should you use it? WeakHashMap is a specialized map implementation where keys are stored as weak references. This means that if a key object is no longer strongly referenced elsewhere in the application, the garbage collector is free to reclaim it. Once the key is collected, the entire entry, key and value is automatically removed from the map. This is extremely useful when you want entries to exist only as long as the key is in active use. Many frameworks use WeakHashMap to store metadata, caches, listeners, or temporary objects without preventing garbage collection. For example, IDEs use it to store editor settings, and Hibernate uses it internally to maintain proxy references. WeakHashMap helps prevent memory leaks in long-running applications by ensuring unused keys don't remain in memory simply because they exist in a map. However, it is not suitable for critical data because entries may disappear at any time when GC runs. Also, weak references apply only to keys, not values. Use WeakHashMap when temporary, auto-expiring data is required without manually cleaning up entries. Next, what is IdentityHashMap and how is it different from HashMap? IdentityHashMap is a map implementation that uses reference equality instead of value equality to compare keys. This means it uses equals rather than equals to determine key uniqueness. In a standard HashMap, two keys are treated as the same if their equals method returns true. In an IdentityHashMap, keys are considered equal only if they reference the exact same object in memory. IdentityHashMap is useful when object identity is more important than logical equality. For example, serialization frameworks, deep cloning libraries, and graph processing utilities use it to track visited nodes based on instance identity rather than value. It also allows null keys but behaves very differently from HashMap because multiple logically equal objects can exist as separate keys. However, IdentityHashMap should never be used as a general purpose map because its behavior defies normal map expectations. Instead, it is a niche utility for framework level development, catching of object identities, or maintaining object graphs.